Hi everyone. In this video I'm going to make myself an electric motor as supplied by the Hodson company. It's a bit of a how-to video, so if you find yourself making one as well in the near future, hopefully this video will help you in the construction of your electric motor. This is the success criteria. Hopefully you'll be able to make a motor that does exactly what you're seeing here on the screen, applying it to a 6-volt battery and getting it to spin. The Hodson motor comes in a cylinder like the one you see here, and we'll be using a 6-volt battery to power our motor. In the classroom, if you're doing it in the classroom, you might use a power pack and be able to vary the voltage up to 12 volts. But for our project, we'll be using a 6-volt battery. These are the parts you should find inside of the Hodson kit. Because we're doing this at home with a 6-volt battery, I'll also be including an alligator clip, an extra alligator clip, and 2 extra magnets. We begin the project assembling the rotor. We've got 2 half-rotor plastic pieces that we put together. We have an axle that they'll be spinning on, and you'll also see in a moment that we have a coil which will then become a part of the rotor around the rotor. The coil will be made from a long piece of wire wound around the rotor. The ends of the wire will be stripped, and these will become our coil leads, and they'll be fastened to one side of the rotor. It's important that we don't fasten it to the side that's already got scorch marks in it or melt marks in it. We want to fasten it to the smooth side. Now it's time to attach the coil. We'll use a red wire. You can see here we've got our rotor with the axle. We've got 2 elastic bands or 2 rubber bands, and we've got our wire stripper. That's an alligator clip, is a wire stripper. We're going to strip the 2.5 centimeters off the end of the red wire, and this will become one of our coil leads. We'll need to attach our coil lead to the smooth bearing tube of our rotor. We can use the axle of the rotor to double over the stripped part of the coil lead wire. This will increase the contact surface that the battery leads are going to have access to when they're leaning against the bearing tube. Throughout the coil construction, we're going to try and keep a tension on the wire so that the coil is nice and tight about the rotor. Here you can see the coil lead is making is basically dimensioned to the same length as the bearing tube, and for the moment we're going to use one of our elastic bands to hold it in place, but we won't push the elastic band all the way to the end of the bearing tube yet. We then start coiling our wire around the rotor under tension, making sure to alternate which side of the bearing tubes our coils go on each time. We're going to make about 12 loops around the rotor, and as we go through it takes a bit of time and a bit of effort, so I've sped it up here. After 12 loops of the coil under tension, we get ready to make our other lead to the coil, our second lead to the coil. We cut it off. I've used wire snippers. You could use scissors there. Keeping the coil under tension, we try to get a sense of how much wire we need. Initially, I cut off a lot more than I needed. Once we figure out how much we need, then we can cut off the excess and trim back 25 millimeters of the coil, exposing the copper for our other lead. as we get ready to attach the second coil lead to the bearing tube, we'll attach the coil lead to the bearing tube on the other side of the bearing tube to the original lead. So they're both at the smooth bearing tube, but this one will need to be attached 180 degrees around the other side of the bearing tube. We'll need to remove the black elastic band in order to attach our second lead, but its job was just to hold the first lead in place, which is definitely done now. Take your time with this part of the construction because the contact between these coil leads and the battery leads are going to make or break this motor. So make sure that the coil is nice and tight, that the leads are secure, and that they're nice and smooth on the bearing tube. When you're satisfied with the placement of the two coil leads and you're confident that they are evenly spaced on either side of the bearing tube and they can't touch each other, then you're going to need to secure them in place with the black rubber bands. Okay, it's taken a while, but I'm just about ready now to put on the rubber bands. The first rubber band goes on. I try to make sure that my coil leads don't get shifted while I put it on. And I put that rubber band down as close to the barrel as I can along the bearing tube so that the coil leads are held tightly into place. When the black rubber band is secure, the first one is secure, I check that the coil leads are still evenly distributed about the bearing tube on either side and that they are a good shape for contact with the battery leads. Next I apply the second rubber band, this one at the very edge of the bearing tube. The two rubber bands are going to act as some sort of rail or barrier system to make sure that the battery leads don't slip away from that part of the bearing tube where the coil leads are attached. So the two rubber bands act as guides for the battery leads as the rotor spins around. When you're satisfied that everything looks good, slip your axle back into the rotor and give it a spin to see that it spins freely and evenly and that it's well balanced. If you use your imagination and look at the top of the rotor to the bearing tube, you'll see that as the rotor spins, each of the coil leads is exposed in turn to whatever is above the rotor in our perspective. So if we were the positive battery lead, we would see first one end of the coil lead and then the other, rotating round and round and round. The two coil leads, the rubber bands, the bearing tube, and this that we're about to do now, all work together to be the commutator for our electric motor. We have a DC supply, so we need a split ring commutator for our motor to make sure that the DC supply creates a current through the coil that's constantly alternating within the coil for direction. So from the coil's perspective, not from our perspective, but from the coil's perspective, the current in the coil is constantly changing from clockwise to anti-clockwise. And it's the commutator that makes this happen. What we're doing now is attaching the battery lead, which is in the red wiring, so we're going to attach this one to our positive terminal of the battery. You'll notice that I've looped it around and I'm going to set up the stripped wire of the red battery lead so that it leans across where the axle will eventually go. It leans across where the axle is going to go. Now I repeat the process with the black battery lead. This will be attached to the negative terminal of my 6-volt battery. And I thread the wire through with the exposed part of that lead at one end facing into the motor. You may need to watch this part of the video a couple of times. I've been making these motors, the Hodson motors, with students for a few years now, and it's this part of the construction that most students find a little bit challenging. The threading of the battery leads and then the positioning of the battery leads so that they lean across where the axle of the rotor is going to go. And they lean in such a way that they press against the coil leads which are fixed to the bearing tube. So it's probably worth watching this part of the video a couple of times to make sure you're happy with how this is going to work. So when you've securely positioned the battery leads, you'll see that the exposed parts of the battery leads are crossed over, and of course this would make a short circuit, except we bend them apart, we lay the axle between them and allow them to bend back or to lean back against the axle. In this part of the video, we're going to make the U-frame of the motor. That part of the motor, the framework, which is going to hold the rotor in place, allow it to turn, and then also allow the battery leads to be applied to the bearing tube and the coil leads that are there. We'll need to attach the alligator clips, which up until now we've been using as wire cutters. So we'll need to attach the alligator clips to the stripped ends of our battery leads, and that'll allow us to easily attach the battery leads to the battery as we wish. Now you'll notice I've unscrewed a part of the alligator clip. I then wrap the exposed battery lead wire around that screw and tighten it back up, and hey presto, we have ourselves an alligator clip attached to our battery lead. And then we'll do the same again. I've just done that with the negative battery lead terminal, negative terminal battery lead, and then we do it again with the positive terminal battery lead. The framework comes in 3 parts, as you can see here, 2 ends and an aluminium U to hold it all together. We've also got an elastic band which creates a bit of a pressure on these 3 parts to make sure they don't come apart as the rotor is spinning around. You'll come to see that the way that I apply the elastic band is a somewhat clumsy fashion because my elastic band is quite loose. Yours might be as well, and I encourage you to use your STEM skills to apply this in the best way that you see fit. The goal here is to make sure that when the electric motor is spinning, that the 2 plastic ends of the motor don't get forced apart and have the whole thing fly apart on you whilst it's in motion. So here's the framework. The framework allows us to hold the rotor, but also gives us a place to put our magnets, so the magnets can create an external field that the rotor is bathed in. Now here you see we have 4 magnets. The original design of the Hodson electric motor kit would only have us using 2 magnets, and I'll apply 2 magnets right now. You need to make sure that the north-south ends of the magnets are in alignment. Now, counter to what you might think, the large surface areas of these magnets are north and south. The large surface area of the magnets are north and south. This is not like our other bar magnets, which are long. These are short, fat bar magnets. And I've aligned them on my framework so that they're both creating a magnetic field that's in the same direction. Now I'm going to try and apply my coil, which spins, and I'm going to pull apart my battery leads and place the coil in between the battery leads so the battery leads lean against the coil leads on my bearing tube of my rotor. The instructions I just said are expressed in the Hodson Motor Kit slide number 6. Pull one plastic end slightly and slide the rotor and axle downwards between the brushes into the axle sockets. So that's what we're trying to do here. Okay, I actually didn't succeed with my first attempt, so here comes my second attempt at doing exactly that. I separate out the battery leads and I try to slide my rotor into the framework that we've created so that the battery leads lean against the coil leads, which are securely fastened to my bearing tube with the black rubber bands. So I'll bring it up close to the camera so you can see what I'm talking about. The battery leads and the bearing leads lean against each other. They're in contact when the coil is horizontal, and when the coil is vertical, they're not in contact. The coil will hopefully spin, the rotor will spin such that the battery leads will come into and out of contact with the coil leads with each rotation. And the positive end of the battery will come into contact with a different coil lead end with each rotation. Okay, here we go. We're going to attach our 6-volt supply. We attach the 6-volt supply. We get the negative terminal added on first. We add the positive terminal. And we see that the coil is currently horizontal, but not much happens. So something's not working. So assuming that the motor has been made well and has good connections everywhere, then the problem's going to be either not enough voltage or not enough magnetic field. I can't change the voltage, so I'm going to increase the magnetic field by doubling it, adding 2 more magnets to either end of my framework, and making sure that they all align north-south, creating the one field. And I can do that with my little compass here. So now that I've doubled the magnetic field, I can apply my voltage again, my 6 volts. But before I do, I make sure that the coil is horizontal, so that when I apply the voltage, there's a connection between the battery leads and the coil leads, and so we'll have a current flowing through the coil straight away. If the coil were vertical when I applied the voltage, then the battery leads wouldn't be touching the coil leads as I applied the voltage. So there'd be no current flowing through the coil and therefore no rotation in the motor. Okay, last check. Everything's in alignment. There's a good strong magnetic field. I've got a 6-volt battery. It's time now to attach the voltage and see if we can get the motor to work. And there you go, it works. As you make your own motor, see if you can take a few images and send them on Sector.